Hey everyone, thank you for joining us tonight in the Omaha Azure user group meeting for the month of September. And we have our speaker, Zoe Hudson. She's a consultant at Sojedi. She's based out of Omaha. With that, I will hand it over to you, Zoe, if you want to talk about Capgemini. Otherwise, you can kickstart your presentation.
I'm not sure too much about what to say about Capgemini besides it being a consulting company. I work for a subset of it called Sojedi. They're slowly transitioning into being more so recognized as Capgemini. Currently, I do a little bit of contract consulting work at a company that I'm contracted out to. I work with really great people. We have really great people mentors. There's really a good encouragement there to learn new things, progress your career. So definitely recommend checking them out if you're interested or need some contractors. Everyone I work with is so smart, it blows my mind every day. So really appreciate it. But anyways, like you said, my name is Zoe Hudson. Today I'm going to be talking about Azure Private Link. So bear with me. If you have any questions, raise your hand, let me know, or just wait until after, and I'm happy to answer. So this is what we're going to be kind of going over today: the what, why, some core components, how, a little bit of architecture, some use cases, best practices, some challenges and limitations, and then answering any questions if you have them. So what is Azure Private Link? Azure Private Link allows you to securely access Azure services like databases or storage without exposing them to the public internet. It creates a private connection between your resources inside a virtual network and Azure services. A little overview of how it works is that you can create a private endpoint, which acts as a private gateway between your virtual network and an Azure service like SQL database. This makes sure that the data never leaves the Azure network, keeping it private and secure. A little bit of why it's important is that it keeps sensitive data secure, and it helps meet compliance and regulatory standards by not exposing services to the public internet. And it streamlines your network by avoiding VPNs, gateways, firewall configurations, things like that. There are a lot of supported services, some main ones being Azure Storage, SQL Database, Azure Key Vault, Cosmos DB, MongoDB app services, and more. Custom and third-party services. So in addition to native Azure services, you can expose your own applications via private link, making them available to clients securely through private endpoints. So you might want to focus on a platform as a service or your own service that's behind a load balancer. You do need a standard load balancer, but a platform as a service is generally exposed by public IP. Even with firewall configs that are on most services, the IP remains public. So this is nice because your IP is private. It's like a big difference. So why use Azure Private Link? You have enhanced security. Azure Private Link eliminates the need for public-facing endpoints, ensuring your services can only be accessed through your private network. This significantly reduces the attack surface. Improve privacy. By keeping data within the Azure backbone network, Private Link ensures your communication is kept private. No data traverses the public internet, reducing the risk of exposure. There's also a log that you can look at to see those interactions with the endpoint. It's kind of useful. And then simplified network architecture. Without a need for complex VPNs, NAT gateways, or firewalls to secure your data, Private Link simplifies network design. You get secure access without worrying about routing traffic through public networks. So a use case would be a financial company handling sensitive data can use Private Link to connect to an Azure SQL database securely, preventing unauthorized access and avoiding public exposure. So some core components that we're going to take a deeper dive into later is the private endpoint. A private endpoint is a network interface connected by your virtual network, allowing you to access Azure services securely. It maps the service's IP address, but remains private. So you can create a private endpoint for Azure SQL, allowing it to be accessed privately within your virtual network. Private link service. A private link allows you to expose your own custom services privately to other users or virtual networks via aliases you will give to them if requested. If you have an application running in Azure and want customers to access it privately, you would use private link service to give them secure access. And then private DNS zones. DNS zones ensure that when a user is within the virtual network, try to resolve a private endpoint like SQL.database.windows.net, It automatically routes to the private IP rather than a public one. That just simplifies the internal name resolution for private endpoints. So this leads you to ask, what is a private endpoint? A private endpoint is essentially a network interface that securely connects us to a specific Azure service. The key point is that it uses a private IP address from our own virtual network, ensuring that all communication stays private and doesn't touch the public internet. This is critical for improving security, especially when you're dealing with sensitive data. So this endpoint is just kind of acting like an IP address, and that's what makes this so flexible compared to like a firewall. So how do private endpoints actually work? When you create a private endpoint, Azure assigns it to a private IP from your virtual network. This private IP is how your resources access the service. A key part of this process is the DNS configuration. Azure uses private DNS zones to map the service's domain name to its private IP address. This ensures that when your application or resource tries to connect to the service, it resolves the private endpoint instead of a public one. Ultimately, all data between your resource and the Azure service flow through Azure's secure private network, keeping your data safe from exposure. Imagine you got a virtual network that contains a virtual machine running your application. You want the virtual machine to connect to Azure's SQL database securely. With Private Link, you create a private endpoint in the virtual network that allows the virtual machine to access the database over private connection, all within Azure's secure environment. In summary, the virtual network acts as a private space within Azure, and Private Link provides the mechanism to connect securely to Azure services within that space. So these are the talked out loud steps of creating a private endpoint. Sorry, I know there's kids shouting. I'm sorry if you guys can hear that online. I do have a video of a demo later that will go over it in more detail. Sorry, we're waiting on some doors closing. Thank you, I appreciate it. So this is a high-level overview of how to create a private endpoint. You're gonna select the Azure service you want to connect to privately, such as Azure Storage or SQL database. Assign the private endpoint in Azure portal, create a private endpoint, assign a private IP from your virtual network. This is the IP your resources will use to connect to the virtual service. And then configure DNS, ensure that your private DNS zones are set up so that the service domain name resolves to a private IP. Finally, test the connectivity. Verify that your resources can access the service privately using an assigned private IP. This ensures that the configuration is working as expected. So, private link versus private endpoints. Let's clarify the difference between Azure Private Link and private endpoints, as these terms are often used together, but they serve slightly different purposes. First, Azure Private Link is the broader service. It's a technology that allows us to privately access Azure services without going through the public internet. It provides a foundation for secure private connections to both Microsoft services and your own applications. Think of a private link as the overall framework for private connectivity. On the other hand, a private endpoint is more specific. It's the network interface that actually connects a particular service to your virtual network. It maps a private IP from your virtual network to the service. For example, if you have an SQL database and you want to connect it privately, you'd create a private endpoint. In short, Private Link is the technology that facilitates private access, while private endpoint is the connection point that it implements it. So when would you use one over the other? Well, you don't actually pick between them. When you set up a private link connection, you're essentially configuring a private endpoint to privately access a service. For most use cases, such as a platform as a service like Azure Storage or SQL, you'll be creating a private endpoint as part of your private link setup. However, private link service, you can also expose your own custom applications securely through all other networks. To summarize, private link refers to an overall capability for private access. Private endpoint is the specific resource that enables this access by connecting to your virtual network as a service. So we're going to go a little bit into DNS because this was also new for me. What is DNS? DNS translate user-friendly domain names, e.g. myapp.example.com, into an IP address that computers use to identify each other on the network. In the context of Azure Private Link, DNS plays a critical role in routing traffic to the correct private endpoint instead of a public endpoint. DNS and Private Link. Azure Private Link uses private DNS zones to map Azure services domain names to the private IP addresses of the private endpoints. This ensures that when a service within a virtual network tries to connect to a resource, the traffic is routed through the private network rather through the public one. It's really nice. It does all that rerouting for you. You don't really have to worry about it. So it's kind of a user-friendly system there. So how does one achieve this with DNS? It uses something called private DNS zones. These DNS zones that are hosted privately within our virtual network, and they work by mapping the domain names of Azure services to the private IP addresses of our private endpoints. Here's how it works step by step. A resource, like a virtual machine in our virtual network, tries to connect to a service. Instead of resolving the service's name to a public IP address, the private DNS zone resolves it to a private IP of the private endpoint. This ensures that the traffic stays within Azure's private backbone network without ever leaving the public internet. This is the beauty of Private Link, allowing us to connect privately and securely through Azure services with DNS handling the behind-the-scenes name resolution. Setting up some private DNS zones. So let's talk about how we actually set this up. Setting up a private DNS zone is fairly straightforward, but it's crucial for making sure that everything works properly within Private Link. First, you'll need to create a private DNS zone within the Azure portal. This can be like a range of IP addresses, and that will typically correspond to the service you're using. For example, if you're setting up Private Link for Azure SQL, you'll create a DNS zone for something like privatelink.database.windows.net. So you'll realize that it automatically reroutes to something with Private Link in it. That's how you kind of tell the difference in the URLs. Next, you link this DNS zone to your virtual network so that the resources in your virtual network can use it for name resolution. Azure will automatically create DNS records for you when you set up a private endpoint, which saves us a lot of manual effort. Lastly, always make sure to verify that the DNS resolution is working. Tools like NSLookup can help you ensure that when a resource tries to access a service, it's resolving to a private IP address and not the public one. Challenges. Of course, with any network setup, there can be challenges, and DNS is no exception when using Private Link. Some common DNS issues we might encounter include DNS mismatch. If we don't set up a DNS zone properly, there's a risk that traffic might still resolve to a public IP address rather than a private endpoint. Multiple DNS zones. This happens a lot with acquisitions. Things can get tricky when managing multiple private DNS zones across different regions or environments, leading to potential misconfigurations. Fortunately, Azure provides some helpful troubleshooting tools. For example, we can use NSLookup or Azure's Network Watcher to trace how domain names are being resolved. If we're using custom DNS servers, we need to ensure that they're correctly forwarding requests to the right DNS zones inside of Azure. So while there are challenges, staying on top of DNS setup with regular audits and testing keeps everything running smoothly. DNS and hybrid connectivity. DNS becomes even more critical when we're working in hybrid cloud environments. In hybrid scenarios, where we have resources both on-premise and in Azure, DNS needs to resolve names consistently across both environments. For example, let's say we want our on-premise systems to access Azure services through Private Link. To achieve this, we need to configure our on-premise DNS servers to resolve Azure services names to private endpoints and not public endpoints. One way to make this happen is through DNS forwarding. We can set up DNS forwarders that route on-premises DNS queries to Azure, ensuring that domain names like myapp.database.windows.net resolve to a private IP address associated within our private endpoints in Azure. This ensures that even in hybrid setup, all traffic from Azure services remains secure and private. To wrap up, here are a few best practices to keep in mind when working with DNS in Azure Private Link. First, always use private DNS zones when setting up Private Link. This simplifies name resolution for resources within your virtual network and helps ensure private traffic always stays private. Second, if you're working in a hybrid environment, make sure to configure DNS forwarding from your on-premise network to Azure. This allows your on-premise systems to access Azure services over Private Link without exposing traffic to public internet. Third, it's important to regularly audit your DNS configurations. A misconfiguration could accidentally route your traffic to public endpoints, defeating the purpose of Private Link. Regular audits help keep everything secure. And finally, use tools like Azure Monitor to keep an eye on DNS health and performance. This helps to detect any DNS resolution issues before they impact your application. By following these best practices, we can ensure that DNS works seamlessly with Azure Private Link, maintaining privacy. Yes, okay. Cool. Now, so I cannot, since this is my own personal laptop, I don't have access to Azure Private Link on here. So this guy is going to do our demo for us. I did share the audio on this sharing thing. I don't know if it'll automatically share on Teams. Didn't think that through. You think it will? Okay. So, oh, what am I doing?
Hello.
Oh, here we go. Oh,
Story and a step-by-step
I have to have it on.
how to configure it in less than 5 minutes on each of the topics. Secret Recipes was a business which provided secret age-old recipes to their customers by charging a subscription using their site www.secretrecipes.com. Let's take a behind-the-scenes look at how the technology is implemented. The base infrastructure consists of a virtual network, which is connected to the Secret Recipes headquarters using ExpressRoute. The virtual network consists of a subnet where we have the web server for the website www.secretrecipes.com. This web server has a private IP address of 10.0.0.4. The backend storage for this website is hosted on an Azure blob storage. In this case, we know that the VM has a private IP of 10.0.0.4 and the Azure blob storage does not. We solved the secure network access from the virtual network to the blob storage in our previous video where we explained virtual network service endpoints. If you haven't already, please do check out the video by clicking on the link above. However, the original ship was on-prem, had a private IP of 10.2.0.4 and wanted the mechanism to access the blob storage. But she could access the blob storage from her PC on premises using the ExpressRoute circuit through the Microsoft peering routing door. But the blob storage account still had a public IP, and the security team was not happy. And the rules dictate that they will not be opening any public IPs access to the firewall. How do we solve this? Well, we can solve this by using Azure Private Cloud. In order to access the platform as a service resources securely using private cloud, let's take a look at what is required. Firstly, we would need to create a private endpoint inside the workload. It's a NIC card inside your private IP space. In this case, the IP is going to be 10.0.0.5. Next thing we want to do is create a private link resource, that is our storage account. We then connect the private link resource to our private endpoints using private link. This way, the traffic intended in the storage account always remains in the private IP space and does not need any public endpoints whatsoever in order to access it from on-prem or the Azure version. Great. The next concern from the security team is data exploitation. Or in other words, can anyone from the Secret Recipes network use this private endpoint to leak confidential data to other storage accounts? Well, the answer is no, and that's the differentiator for Azure Private Link. You would only tie specific chosen Azure resources to this private endpoint. Great. Here is the list of resources that currently work with Private Link, and the list is constantly growing. Let's take a look at how you would create this from the Azure network. This is the Secret Recipes resource group. This is where I have the virtual machine, virtual network, and the blob storage. What we want to do is enable private endpoint for this particular storage account. In order to do that, let's look for private link service. Click on private endpoint and then choose add. Let's click the subscription resource group and give it a name. We'll choose the region and the resource. This is where we choose the private link resource for which we want the private endpoint for. In this case, it's going to be storage. I then pick my secret recipes blob storage account and choose blob. Once I click next, I choose the virtual network and the subnet where I want this private endpoint to be residing in. I'm going to leave the private DNS zone enabled to yes. This helps in resolving the URL of the storage account or private IP from my Azure virtual network. The private endpoint is now created. If I look at the properties, I see that the private endpoint is created in my secret recipes virtual network and my subnet. I also see a corresponding link card created, which is what provides the private IP. And below, I see my private DNS zone entry, resolving all private IP from within my virtual network. If you're trying to access this from on-premise, you would want to have a corresponding DNS entry pointing to the private IP for the storage account. The secret recipes business was doing really well. They come across another California-based startup called Easy Vegan Foods, which could further boost their business. Secret Recipes decided to acquire this company to have access to the awesome vegan recipes. And the cool thing was Easy Vegan Foods was also hosted in an Azure virtual network, which hosted their web server with a private IP address of 10.0.0.0.4. They exposed their site to www.easyveganfood using a public IP on a standard load balancer. This way, anyone, including Secret Recipes, could access their sites. But we all know secret recipe security rules, don't we? No public IPs. Well, so the IT team considered having a virtual network peering between both of these virtual networks since they were both in Azure. But obviously, that won't work because of the overlapping IP addresses. So how do we solve this? Let's explore private link service. In order to get started, first let's create a standard load balancer with a private IP address of 10.0.0.6. We will then create a private link service over the standard load balancer for consumption from the secret recipe subscription. Create the private link service so that we can expose the service from Easy Vegan Foods to be later consumed by secret recipes virtual network. While creating the service, we have the option of limiting the exposure of the Easy Vegan Food service by either using role-based access control, subscription name, or making it available to anyone with the alias for the service. Now, going back to the source secret recipes virtual network, we create a private endpoint which has an IP address of 10.0.0.10. Remember, this IP comes from the secret recipes virtual network and not from the Easy Vegan Foods virtual network. Using this private endpoint, we connect with the private link service provided by the Easy Vegan Foods virtual networks. We have now made available the website www.easyveganfoods from the secret recipes virtual network privately without traversing the public internet and without having a virtual network peering between the virtual network. How cool is it? Well, let's take a look at how we implement this from the Azure. We are now logged into the Easy Vegan Foods Azure subscription. We see the web server, the storage account, and the internet. What we want to do is create a standard load balancer for the web server. We click on load balancer, choose the resource group, give it a name, choose the type as standard, and make it internal because we don't want a public IP. You also want to choose where you have this private IP with load balancer residing. I'm going to choose the web subnet and give a static IP of 10.0.0.6. Let's create. The first thing we want to do is add the web server VM to the backend of the standard load balancer. We also want to ensure you have the blended IP configurations, health prompts, and the load balancing in place. Now that all are in place, let's go to the private link service. Click on Expose your own service so that others can connect to it. Click on Start. Choose the resource group, give it a name, and the region. Let's click on Optimal Settings. I want to choose my load balancer, which is created that is SLB-Web Vegan. I also want to have the source NAT subnet chosen. In this case, I want this IPs to be coming from my web subnet. I'm going to leave everything else as default. If I click on next, here's where I have the option of restricting the exposure of my service to the others. I can either choose always access control based on a user ID or restrict it by subscriptions or give anyone access that has an alias of my service. I'm going to choose subscription in this case and add the second recipe subscription here and make it working. Click on the Beacon private link service. Copy this alias. Now I'm going to switch over to the secret recipes Azure subscription. I click on start under build a private link connection to a service. I choose the subscription resource group, give it a name. I then click on next. Here I want to choose connect to an Azure resource by resource ID or alias and enter in the alias from my Beacon food subscription. I enter the Winstop for although if you remember we had chosen it from .com for the subscription. This is where I select the IP address of our secret recipes virtual network where we want the private endpoint to be residing in and create. The deployment is now complete. If I click on go to resource, I see that the connection status is on because I chose auto. And I now have a private IP from my secret recipes VNet from which I can access the easy vegan food website without having a public IP or a virtual network. I hope you found this video useful. Thank you for watching.
Yay. That was the simplest online demo for Private Link that I could find. So thanks for watching along for that. I would have used my work laptop, but that was not allowed. And I personally am not going to pay for it. So that was the best way I figured to give a demo. Please do not play again. All right. Now we're going to talk architecture. This is the most basic diagram they have on the Microsoft Learn site. It's just talking about on-premises VMs using an express gateway, using a private endpoint, that private endpoint matching what private link service is looking for, that processing it through the standard load balancer, and then boom, you get to your subnet, you get access to all your things. Let me make sure I change this. I'm gonna try to, hopefully you can kind of see my mouse. Yeah, okay, sweet. So this is an example where your virtual network has 3 subnets. And I have created, you can create multiple private endpoints, but this one is just talking about a private endpoint is going to create a read-only network interface on the subnet that you pick. It'll get your IP address from that subnet that represents a particular instance of the service. So allowing your specific virtual network or specific subnet access to a storage account that we have over here, like blob storage or file storage, and not by the public IP by creating a private endpoint that would have its own specific private IP address. You can create multiple private endpoints to use separate services across multiple different virtual networks. You can also control if the service can be accessed by only private endpoints and not all networks, and vice versa. It's a quick little toggle on there. And like he just demonstrated, you'll give the endpoint a region, a service, and a virtual network to use. Endpoints can access the same service even with different subscription services or regions. It's just acting as an IP address. So just think of it as that and not so much as an endpoint. And then it becomes more flexible through that. You can talk to this. Let's say you're using a virtual network and you're peering into an on-premise virtual network. That's the same path. It's going to go straight through and recognize it as the same IP address and go to blob storage. Or if you're on-premise and you're on-premises using a virtual machine that accesses that virtual network, it's going to recognize it as the same private endpoint, private IP address, and get through to blob files as well. It's really cool for disaster recovery. So you can have endpoints that access the same service throughout different regions. If one region with endpoints goes down, endpoints in a different region can still access it. It's a little different if the region that the service is in goes down, but if the service recovers to a different region, then the endpoints will automatically route to the region it's up in. So that's pretty cool. Hopefully it won't play this. This is just some guy that I wanted to shout out to you. If you really are interested in this after, I don't know. He does a really, really great deep dive, but it's a lot more technical jargon, but he's a great resource. The only issue is if you know Wallace and Gromit, he kind of sounds like Wallace, so you got to get over the voice a little bit, but he is very smart. And that's just like, please don't. No. Okay, we're good. Okay, so use cases for private link. So like I've been talking about data security, so you're going to be handling highly sensitive data like medical records or financial transactions. Azure Private Link ensures that only authorized applications and users can access your resources through a private and secure path. Many industries have strict protection regulations. If you guys are cybersecurity people, you're probably so done with all of the regulations that keep popping up. Like HIPAA or GDPR, Private Link can help meet these compliance requirements by ensuring that data is not exposed to the public internet. And then we talked about hybrid cloud architectures in scenarios where you're bridging between on-premise environments and Azure. Private Link can securely connect on-premise applications to Azure services over private connections. If you're a software provider, software as a service, offering services to customers, Private Link allows you to expose your services securely to each customer's private network without using a public internet endpoint. So what are some best practices so that you can stay like this smiling dog and not be the sad crying dog? So security, you're going to want to use network security groups to control which resources can access your private endpoint. You can create network security group rules to allow only specific subnets or IP ranges or roles. You want to make sure that you have high availability. Consider deploying multiple private endpoints across different regions. This ensures that if one region experiences issues, your service remains accessible through another region. And then you can use Azure Monitor and Azure Security Center to keep track of private endpoints and monitor the usage. And then you're going to want to regularly audit each endpoint to ensure compliance with security policies. Of course, with anything, there are challenges and limitations. We talked about DNS configuration. So managing DNS can become really complex, especially when you have many private endpoints. You must ensure that the correct private DNS zones are configured and integrated with your virtual network. Not every Azure service supports private link yet, so sad, but they have all the services they do support on their website. Although they're going to continue to expand, and they most likely already have launch dates for the ones they don't have them on. Private link also, while ensuring secure connections, the indirect routing through private endpoints can introduce a small amount of additional latency. However, I feel like it's worth it for the security benefit. It's a little negligible, but just making sure it does slow you down if quickness is what you care about the most. So we're going to talk about recent developments. And this is where I'm about to spew, and I'm very sorry about that. One of the exciting recent developments in Azure Private Link is the broader range of supported services, like I just talked about. Initially, Private Link focused on core services like Azure Storage, SQL Database, and Cosmos DB. However, with the recent updates, support has been extended to more Azure services, significantly enhancing the flexibility of Private Link in cloud architectures. For example, you can now connect AKS privately. Everybody loves Kubernetes, right? They're the hottest new thing. It's a big deal. AKS is often used for containerization applications that need to interact with Azure services. Previously, many of these interactions required public endpoints, exposing traffic to potential vulnerabilities on the internet. But now using Private Link, we connect AKS cluster to Azure services like Azure SQL or storage without ever exposing traffic to the public internet. This brings a higher level of security and control to containerized workloads running in Azure. Azure Event Hubs and Azure App Configuration are also among the newly supported services. Event Hubs is used to process massive streams of data in real time. And with Private Link support, you can stream data securely from internal systems without going through public endpoints. Similarly, App Configuration allows you to manage configuration settings in your applications centrally, and Private Link ensures those settings are accessed securely from within your own network. In addition to Azure's native services, third-party services are increasingly adopting Private Link as well. This allows private access to their APIs and services, further expanding private connectivity options. For instance, if you're using a third-party SaaS solution and that supports Private Link, you can now interact with it in the same secure manner that you do with other Azure services. This unified approach simplifies the architecture because you no longer have to configure multiple security layers or rely on public endpoints. The benefits of these expanded capabilities are pretty clear. We get a much more seamless integration across a wider variety of Azure services, all under a single secure connectivity model. This improves security, reduces complexity, and streamlines how we manage our network. We can now create private connections to services that traditionally required public endpoints. This extends the range of workloads we can secure using Private Link without having to manage separate VPNs or public-facing firewalls. An example of this scenario where you're running an application in an AKS cluster that needs to connect to a backend database hosted in Azure SQL. In the past, you might have had to expose parts of your infrastructure to the public internet to enable this communication. But with Private Link, the AKS cluster can interact with the SQL database securely over private IPs within Azure's backbone network. This means that not only the traffic shielded from public exposure, but the network latency is reduced and overall performance is improved. This broadening of support services under Private Link opens up many more possibilities for securing your Azure environment and integrating various services without compromising on security or performance. Whether it's for platform as a service, third-party APIs, or even custom applications, you now have even more flexibility to securely interconnect everything with a unified private network architecture. And then we have some enhanced security features. Azure Private Link also introduced several features that provide granular access control, allowing you to manage and secure private connections with a greater precision. First, there are new enhancements to the network security groups. NSGs now provide tighter control over who can access private endpoints, allowing you to define specific security rules. For example, you can create rules that limit access to certain services based on IP address or subnets, ensuring that only trusted resources can communicate with your private endpoints. In addition, role-based access control plays a crucial role. With role-based access control, you can apply specific rules that restrict access to the network level. This lets you designate who can manage or access private endpoints, adding another layer of security beyond NSG rules. There are also the introduction of private endpoint policies. These policies let you define rules that can control which resource or users can establish private endpoint connections. You can even go a step further by implementing conditional access policies. For example, you can enforce multi-factor authentication, MFA, or restrict access to certain devices, ensuring only authenticated and secure devices can interact with your private endpoints. I know how much we all love MFA. Am I right, guys? Lastly, advanced encryption has been improved. Private Link can now support stronger end-to-end encryption for traffic, ensuring that data remains secure in transit and at rest. This means not only is your network protected as it flows through Azure's backbone, but also that any data stored in Azure services is safeguarded by encryption protocols. And then we have new monitoring and diagnostic tools. Another exciting update is the integration of Azure Monitor with Private Link. This integration provides real-time visibility into your private endpoint connections, which means you can now monitor how these connections are performing more closely. You get access to detailed metrics like data transfer, latency, and overall health of the connections. This is crucial for ensuring everything runs smoothly and for identifying any potential bottlenecks. Azure has also introduced new tools for private link diagnostics, which enhance your capability to troubleshoot connection issues. For example, if you're experiencing problems like DNS resolution errors or connectivity failures, these advanced diagnostics provide more insight into what might be wrong. You can also set up customizable logs and alerts through Azure Monitor and Log Analytics. This feature helps teams respond quickly when there's an issue by triggering alerts as a problem is detected. Instead of waiting for the issue to escalate, you can act immediately. Imagine a company is facing intermittent connectivity issues with their private link connections. Previously, troubleshooting might have involved trial and error, but now with the detailed diagnostics available, they can quickly identify whether the issue is related to DNS misconfiguration or routing problem and resolve it much faster than before. And thanks for your time. I hope it was well spent and you learned something. My email is there, my LinkedIn. If you have any questions, you can always email me or add me on LinkedIn. I'll also share out this slideshow. These are some really nice links to look at that go deeper into architecture, as well as answering some questions as to why this over glass or firewalls or things like that. And it also has a pricing structure. And you guys are really up there in your company and you want to introduce it. But I did not want to talk pricing structure today. But anyways, that is all I have today. Thanks for bearing with me.